So on this question, we're looking at Maxwell Boltzmann distribution curves. First question here is about labelling the axes. It's important that you know what the axes are. It actually helps you to understand a lot of what's happening within this particular topic as well. So relatively straightforward. The x-axis should be labelled energy, and that will get you mark number 1. In terms of sketching the distribution curve for the sample at a higher temperature, you've got to know a lot of specific information about what's going to make this right. It does need to be a smooth curve. The peak needs to shift to the right and down. Now, it makes sense that more particles will have higher energies. So, of course, my most probable energy is going to shift. And we can see here it's shifted to the right. Because more particles have more energy, there will be less that will have that most probable energy. I often liken this to the idea of stretching a balloon out. It can't stick out as much as it previously did. You're flattening it as you extend it. To get the second mark, because that will get you the first one, peak to the right and down. Second mark, you need to start at the origin. It should be a shallower gradient than the initial one. It should only cross the line once, and it tends back towards the x-axis, but it will never come back down to reach the original curve again, and certainly will never get to the x-axis. For 1.3, 2 marks again, the gas decomposes on heating. Explain why an increase in temperature increases the rate at which this gas decomposes. So it's your knowledge of collision theory that we're looking for on this one. 1. More molecules will have energy equal to or greater than the activation energy. That makes sense when you're at a higher temperature because they're moving faster. There's greater kinetic energy. And if that is the case, that more have energy equal to or greater than the activation energy, then there will be a higher frequency of successful collisions.